Let's take a look at least part of the problem. And I guess should have had a tablet up and running. Okay. Suppose a simple random sample of size n is equal to 200 is obtained from a population whose size is n is equal to 20,000. And whose population proportion with a specified characteristic is p is equal to 0.8. Okay, the first one you got, so I'll leave that alone. So I'm starting down here at mu sub p hat. And I know you got these two also, but they kind of lead into my steps. Okay, step one is find the mean and standard deviation. Mu sub p hat is equal to p. So this is like step one. Mu sub p hat is equal to p. So mu sub p hat is equal to 0.8. Okay, sigma sub p hat. Remember, sigma is your population standard deviation. Is equal to the square root of p times 1 minus p over n. And p is 0.8 times 1 minus 0.8 divided by little n, which is 200. Now, I'm not going to waste time plugging this into the calculator. You got it right here. So that's 0.02 8. Oh, my eyes are bad. 028284. Okay, that's step one. Now, step two. Convert the value you're working with to a z-score. Round z-score to 2 decimal places. So we got z is equal to p hat minus mu sub p hat over sigma sub p hat. Okay, now let's take a look at what they're asking for. What is probably obtaining x equals 166 more individuals with a characteristic? And normally we'd have to switch this to p hat because that's what we're looking for is p hat. And p hat is equal to x over n. So it wouldn't be a big deal to switch it. Because they tell us x is 166. And they tell us little n is 200. Like that. But they go ahead and they tell you that p hat converted over is 0.83. Okay, so they're telling us p hat is 0.83 minus mu sub p hat, which is 0.8, over sigma sub p hat, which is 0.028284. Have to be careful when you plug these in your calculator. You want to put, if you got more than a single number on top or bottom, you have to put parentheses on it. So put parentheses on top part when we plug it in. And do I even have my calculator handy? Oh, there it is. Okay. Actually, let me show it on this calculator since I want to show you the normal CDF anyway. It's coming up. Okay. So I went to beginning parentheses and 0.83 minus 0.8 closing parentheses divided by 0.28 0.028. Okay, let's try this again. 0.028 284. And then press enter. Now I'll take it 2 decimal places. So this would give us 1.06? Yeah, 1.06. Okay, back to our PowerPoint. Step 3 says plug in one of the following 3 forms. Well, if I think of what this is asking for, they tell us p hat is 0.83. And they say what's the probability that p hat is greater than or equal to 0.83? Greater than or equal to means you shade to the right. And these 3 forms you see here, this first one here, that's when it's shaded to the right. The second one is when it's shaded to the left. And this last one is when it's shaded in between. So we're going to use our first form. So we'll do normal CDF, comma, and then it tells us put Z in. Well, we just found Z down here at 1.06, comma, E99, comma, and then it tells us 01. Okay, let's see how that goes. Where's my calculator? Okay, the second vars. I'll choose normal CDF. Did I press down arrow? Try again. I don't know what happened there. Okay, normal CDF 1.06, comma, E99, so second, comma, 99, comma, 0, comma, 1. And close parentheses and then enter. And I'm assuming 4 decimal places, so 0.1446. Round to 4 decimal places. 0.1446. Was that it? Yeah. Let me check this. And that's how you'd find that. Now, some problems will give you p-hat directly like this, and some problems you will have to use this formula to find p-hat. They'll give you the x, and you have to plug it into here. Now, this is just one z here. Down here, you see where it says z sub 1, z sub 2. That's when it's between two values. Then you need to do step 2 twice, once for each particular value.